welcome everyone to our first GCP related meetup this year. My name is Elizabeth Tippan, and I'm a co organizer at the GDG Cloud Budapest. And I will be your host today, while Zsigmond P. Todt will be our moderator from GDG Budapest. Today's session is about filtering phishing emails, which is due to the current international events is quite important. And I hope you will think that you can learn a lot from this event. Your questions and comments are most welcome. Please drop them in the chat, and our presenter will answer the question. Our speaker is Goran Minov from Okta Incorporated, and he knows a lot more about this topic than I do. So let me hand over to him and enjoy.
Thanks, Elizabeth. Hi, everyone. Thanks for the introduction. So, as mentioned, my name is Goran Minov, technical support engineer working at Okta currently. And what I will do is I will try to give I would say it's somewhere between a beginning and intermediate session about how we will be able to create our own phishing email framework hosted on GCP by utilizing various products. So what I will do is I will start by sharing my screen. So we'll be able to start with that. So yeah, as mentioned, another introduction. That's my Twitter handle. So if everyone would like to connect, please do feel free to connect over there. Just if there is any questions that will be unable to answer during this session, and if you have any further future follow-ups. So we will try to divide this session in four main parts. So the first part is where we'll be talking about phishing. So this will be providing details about phishing in general, and according to my research and studies and what this has been published out there as well from another researchers, what is phishing, details about it, and so on. Next thing what we can do is we can talk about the phishing email framework, or PAF, that I would like to call it as in short. So whenever we do any framework, we have a couple of things that we will need to think about that. So we have framework requirements, we have framework design, and we have framework implementation. It's very, very important for these steps to be done as they should. Just as if we do not have a good requirements and we don't have the good design, we will not be able to get this phishing email framework, or any actually framework, implemented. So long story short, starting with the first one, which is regarding with the phishing. So as you probably most of you are aware, hopefully, I find phishing very fascinating in the way of trying to get everyone to trick to acquire like a personal data. With that in hands, the online fraud techniques and methods are to require sensitive personal data such as logins and passwords, or another sensitive personal data like that, but like both significantly improved since. So one's process of obtaining such information is to pretend to be, for example, a page on which the user already has an account. So it's very easily that you'll be able, let's say, your Gmail login, someone to create an exact replica of that Gmail login. However, it's not. So what it will do is that will actually acquire your login. So then the actor will either log on your behalf to do any malicious, or will be actually use that for a data harvest, and then so on. So in computer system, there is like a massive organized data sets and powerful parallel computing machines, and machine learning was very, very quickly adopted due to the enormous quantity of data present. So underlying this, the security of the identity, an email address is required for literally social media, let's say financial papers, and data also saved in the cloud. So maintaining this ultimate level of trust is put at risk when one of accounts for a victim's email password or recovery question is actually compromised. So the victim's credential can be reset in a step-by-step attack in which one credential reset is followed by the downloading of sensitive information and erasure of that information, any backup of use that of my information for malicious purposes. So in short, that is literally like what is it for the phishing. There's a couple of propositions that we can look at when it comes to the phishing. So looking at the research out there, there is a very, very tight relationship between phishing and the presence of urgency, authority. So what this means is that how much of our of like, let's say like our critical infrastructure is left susceptible to intrusions and other dangers because of the rise of cybercrime. According to the systems that allow for the identification and prevention of malware, it is almost certain that artificial intelligence is required for better and more intelligent systems. So this framework, it looks like in general, it actually seems to be necessary as it may contribute to the body of literature on phishing while examining the merits and drawbacks of various approaches to artificial intelligence, including machine learning, natural language processing, and other aspects. So by the look of it and the tight presence, the first thing that the attackers, when they use this method, is that they are requiring the urgency over there. So they would have the details where they would literally try to implement an emergency of something where you will be needed to take an immediate action. So, for example, let's say you are using any of the banks and they will send an email or they will send a text message pretending to be that bank saying that there has been unauthorized access, so you would need to visit this URL for you to be do these steps. So that is something, the urgency. So um, most of the times you would think twice before doing that, but sometimes if there is a like a big coincidence that you actually have an account with that bank, you will probably click on that link and go. So the phishing can be done whether they will be harvest your data or there will be a malicious file downloaded. So then after that, if you're on a corporate network, they will be able to get access to that corporate network. Second thing is the authority. There's a many attempts where they pretend to be your line manager or someone more on chief level, such as let's say like a chief security officer, chief executive officer. Well, they will pretend to be that and ask for you to do a couple of steps. So just because of that authority or something that comes from your line manager, you will most likely think to do that just because of something that comes from them. They usually use a very long URLs to be able to mask that. The latest one that I have seen is that there has been a plenty attempts where they change the URL just a little. So, for example, this is just an example. Let's say if this is a google.com, one of the O's will be a zero or something like that. So they will be able to do that. Or, but I know on Google's level, all that has been blocked. So, but it's just like a pure example. Then we have the incredible deals, which we all know is that they would try to offer you whether it would be very great holidays for you to enjoy, but you would need to provide them your details, or they would like to give you money, but they would need your bank account, or they would need to for you to send them a certain amount of money so they will be able to do the transfer of a lot of money, so to say. And the last one is financial information request, where they would sometimes pretend that they're coming from a human resources or your payroll, where they would actually send pretend to be you and send details to the payroll or the human resources, uh, confirming that you have actually changed your bank account, and for them to update the systems over there, so you will be able to get your next salary. So that is in a nutshell with regards to the phishing. And the next step what we're going to talk about is about the framework requirements. So there's a couple of requirements that we need to think about this. The first requirement is regards to the functional requirement, and the second one is regards to non-functional requirement. So the functional requirement is directly related to the framework, right? So this is something that the framework will need to do in order to be functional. So what this needs to be done? So the framework will need to monitor for new emails within the user mailbox. So then we will be able to utilize that framework and let the end user tell them whether that email is a phishing or no. We will need to be able to label the newly received email to inform the end user that phishing scanning is pending. We need to extract all the details, the content, links, attachment, domain, and everything. We will need to get all those details, combine them. It will, in the end, we will need to predict and inform the user um, of the outcome. We will need to be, if there is an attachment, we need to scan the attached document as well, and also predict if that email attachment content is safe or not by sending details to, in our case, we will utilize a natural language model. We need to predict if the email content is safe, like we mentioned, and we need to see also the links and the whole details if it's safe or not by using custom natural language model. And for the links, we will be utilizing a Google Safe browsing, which I will give a more details a little later. So having all this into consideration, we will need to combine all these details in the end, and then be able to inform that user by, let's say in this case, because we will be utilizing the Gmail API, by labeling whether or not that email is secure, or is it phishing or not phishing. The non-functional requirement is what we need to have in order to be able that user to get this framework, right? So it's not directly related to the framework, but these steps or these requirements will need to be fulfilled in order for that framework to be deployed or be able to working for that end user, and also to be widely accepted. So what we need to do is we need to have someone to register for that framework by using any instructions. In our case, the non-functional requirement, because of what we use, the products we use, it needs to be deployed on GCP. So that is a requirement. If we were not able to deploy to any other public cloud provider or private one without doing any modification, just because this has been specifically built for Google Cloud Platform. The user, based on clicking on that or following that step, will need to provide a consent to that mailbox within a web browser, and the email access request should clearly state which scope we would need. In our case, we need to clearly state that we will need a view access to the email, but also we need to have an edit access to the email, just because we will need to edit those emails and append or remove labeling for that one. So the last two ones are regards to the how fast this framework will need to work. So the initial email labeling, or the pending, so to say, email labeling, that email we have noted has been received in the mailbox but is not yet scanned, needs to take at least maximum 2 seconds. Why is that? Well, if the initial email labeling will take around 5, 10, 20 seconds, there are higher possibility that once you receive that email, comes into your mail, you already clicked on that email and it has been opened. So there is a bigger chance, or bigger risk, that that user has already clicked, that email is open, and now we have labeled after, let's say, like a 5 minutes, that that email is actually malicious, but that user has already opened. And the framework should take no longer than 10 seconds to provide an outcome. So maximum 2 seconds, we label as pending, we extract all the details, find the outcome and label that again, whether it's phishing or not, within 10 seconds. So that is very, very crucial in order for this framework to be accepted. Next thing we're talking about is the framework design. As mentioned before, the architecture that we're gonna have is we're gonna have a 4 main architecture parts. The first thing is we will utilize the Gmail API. We will use a Cloud Pops Up, which is a publisher and subscriber tool solely so we can be able to manage that Cloud Functions invocation, the main reason, and also we'll be able to subscribe to those new event emails in Gmail API. Gmail API has a very, very good tight relationship with the PubSub, where on a click on a button, you will be able to do that and invoke. And of course, we will use an AutoML or the natural language model or cloud machine learning. As it is, there is a many names behind this product, but the actual is AutoML. We will also utilize a data store. So we will store some of the data over there, but that data will be encrypted and that data will be actually unknown. And there's a little reasoning behind that, to which once we're gonna be go through the details, I will be able to provide. But the 4 main is that these ones that you can see on the screen. So each component will provide a unique function, right? So the Gmail API, we said we use for Gmail monitoring and push notifications to PubSub. Then PubSub will be the component between the Gmail API and the Cloud Functions, and then Cloud Functions will then be using to literally extract and send the relevant details to AutoML. Then the AutoML enables computer systems to understand and extract the structure and content of the text or links or whatever it is. So we can have an improved understanding of social media sentiment, consumer interactions, information about people, locations, and events that might be extracted. So the whole process is this, where going from the beginning is the Gmail API with the PubSub, and then is the invocation between Cloud Function, sending over to AutoML, PubSub, AutoML, PubSub, AutoML, PubSub. So a lot to take in this photo, in this slide. Will not be get too much details on it, just because what we're going to do is we will come back to this one at the end, where it will first we will dissect everything step by step, and then we'll come back to it just so we can get a better understanding. So we've come to the main part, what is the framework implementation. So right now we know what is our requirement, right? So our requirement is that we have a functional and non-functional. So we need to get everything that we have designed in step 2, put or implement here together, so that we will meet all the functional and non-functional requirement in step 1. Slowly, our framework comes together, so to say. So on next up, first we're going to start is that we will need to have data sets for the natural language model or AutoML. You will be able to use that data set for a single classification in our case. So single classification is that whether we're going to have a yes or no, a 0, 1, true, false. So that's the only thing we care, right? Just because we don't want to get yes, maybe, no, or I don't know, or anything like that. So what we're going to do is we're going to get that data set, we're going to send it to AutoML, and we will train that. Once we will train that, we will be able to utilize that single classification, like single model classification, and get that 0 and 1. So it might not be 0 and 1, because it can be any number between 0 and 1. But however, if it is 0.95, that there is a very, very good chance. I think actually in machine learning side, I should not say 100%. So I think I just say there's a very, very good chance that that thing is, well, it's phishing or it's not phishing. It depends on how we would like to interpret that. So I have used two data sets for this. One data set was for the URL, and the other one was for the emails or the messages that we come to. So the reason behind this is that we all know when we receive an email, we have a sender. So that sender comes from a domain that has been registered, unless it's from a public email provider, such as Gmail or Outlook or Hotmail.com. So, but that one still would have a domain, but it will not be tied to the organization or whatever who the person it is that they have created their custom email domain. Um, the other reasoning as well is that there is a lot of URL or links that are included into the email to trick you to click on that, so you'll be able to visit some website. I have found a very good, so these two data sets that I have found, they're actually publicly available. And the one that I found for your URL, it is, as you can see, it's almost 96,000 URL inside, and they are divided in half after cleaning the data and stuff. It was a 96, and they were divided in half. Half was phishing. The other one was actually legitimate. And this actually helped to get a better understanding on the AutoML model, because they so the only reason we use the AutoML model in this site is that they will get a better grasp of how is those emails are um, created, so to say, or so the links that they are, for example, longer, or they have a subdomain on, so they have a subdomain.subdomain.domain.com or anything like that. If they would see that there is many of those ones that are like that, then there is a high chance that once they're going to scan that text, they're going to be like, okay, this text is actually phishing, or this text is legitimate. Or funnily enough, gmail.com as well, it comes a lot of times here when it comes to the links, or comes as a sender just because it's a free and a public out there. And the email one is a little less. It's like only 5,000 messages, and this is to get that sentiment, to get that details of urgency, to get that if they're trying to trick to get some details out of it, to get that whole, to scan that whole email body and get actually if the AutoML model thinks that whatever you have received an email, there is a high chance that that one is a phishing. So after that one has been done, we could have seen that the graph that we get at the end. So the actual URL model took around 8 hours for the 96,000 entries, and around just a couple of hours in order to be trained. So this is all automatic. You just literally clean the data, get it into a format, upload it to AutoML, and then AutoML trains it. At the end of the training, once you get that results, you will see the precision and the recall. So to get an idea actually how ready the model is, precision and recall, and how highly scored on the F1 score, like I used. A high precision model produces fewer false positives, while a high recall model produces fewer false negatives. So it is very important to get this here as well, the false negatives and the false positives, right? So looking at the precision, we have almost 99.58%. So that's like we are confident, or the AutoML model is confident, we will get a lot less of false positives. So precision actually indicates the percentage of times the model predicted the positive class correctly, right? So where the true positives are divided by the sum of the true positives and the false positives. And a recall is a classifier affected at determining the correct class, right, for the training data set. So in real world, let's say it's like how many positive terms actually the model did or detected. Looking at the URL model, we can see like a high precision, a high recall, but also in the messages model, we can see a high precision, a high recall. But it's very important to note here the high precision and high recall is based on the amount of data we have given. So getting a 96,000 data sets compared to 5,000 data set, or compared to 150 millions, for example, will not, let's say, it will not perform the same. So the model will not perform the same. So this is the precision and recall is done based on the data, or the data sets that we have. So it is actually a 99.41% precise that I will produce a fewer false positives based on the 5,000 messages that I have sent as a data set. I might send another 500,000 and I get a 98%, but still that 98% from a 500,000 will be much, much better. So a few, to summarize, actually, a better or a larger data set is always, always welcome, and it's always, always encouraged to be done. Next thing we're going to say is the actual cloud functions, right? So the first steps that we need to do is to write a cloud function. So first thing we need to do is we need to get that functioning, or non-functioning, actually. So that non-functioning requirement here to be able to enable. So that non-functional requirement, if you do remember, it's actually relates to the granting consent. So the user needs to grant the consent to the framework, to their mailbox, by clicking a URL and logging in, or by following some other steps, let's say. But mostly it's clicking URL, you log in with your email, and then over there you will get that pop-up where you will say that this framework will actually need access to view, edit your emails, right? So that will be done by the authorization cloud functions. So the use cases here that we have is that at the beginning, user grants the phishing email framework access to their Gmail account. Once that is granted, we execute the auth_init function, which is the second one. So that what it will do is that it will go and will actually authorize, initiate the authorization. So that is in authorization initiate, and then it will pass the data that we need to the callback. So that data that we need to the callback is the email ID, and that's it. We do not anything. We do not need anything over there. We already have access to the user's mailbox. We have provided consent. We have provided a scope, and all we need is just that email ID. Now, that email ID will actually be used to set up the subscribing to PubSub. We'll be able to set up what we need as well in order to get those things done. So what do we need here? We have mentioned over there that we're going to use the Gmail API to subscribe to PubSub for that new email. And also, we will need to use labels. So that cloud function will initiate will actually publish to two subscribing events on PubSub, and the one will be email watch. So that email watch will be used to the Gmail API to subscribe for any new email. So once the new email will be received, then they're going to publish an event or a message, how do you want to call it, to PubSub, to that one, to email watch. The other one will be email labels, and that email labels will publish, and then we'll invoke the email labels cloud function. The email watch will set up Gmail notifications, but the email labels will actually need to do a little heavy lifting over here. So we have mentioned before, we have the email ID. What we need to do right now is that we will need to go out to that user mailbox. We need to check if that user have that labels, because we would need to use that labels in order to get that to actually do that labeling on the emails, depending on if the email is pending, if the email is secured, or it's not phishing, or the email is unsecured or phishing. So what we do is we'll call an API to Gmail. We will get details from there, and we will actually query if there is any labels over there So the labels that I have choose, or the label names, will be pending, secured, and unsecured. If we confirm that those three are not there, then what we're gonna do is actually check data store. This is where we talked about data store, right? So we're gonna check data store and we're gonna see if we have that email ID, or actually there will be an encrypted email ID over there, and if there is any labels as well there. If there is not, then what we need to do is that we will need to initiate a label creation over there. So those labels, we need to create them and we need to append the correct ones. Why do we need that? Because append those ones and append them with the correct labeling. What do after that we'll do is we're gonna get that label ID, and then we're just gonna use that label ID to do the labeling, and it's gonna be much easier for us for the next steps. So um, we just a little code example over here. Node.js, very easy. What we do is just do an API call to users.labels.create, and then we send. So the user ID is the email, what that we are, or the email ID. It depends on that, and then we just create it. So the name of that will be pending, and then we have a text color and background color. Text color and background color, it depends how you want to do it. In my case, for the pending, it's actually yellow. Simulate the traffic lights is actually yellow, which means to the user, hey, get ready. I will tell you what is going to happen next. Green will be, this is secure, you're good to go. Red will be, this is unsecure, you're good to go. And also as simulating it as the traffic lights, if that user actually do some action while we have labeled that email as red, there will be a consequences such as real life, where there will be some points maybe on your driving license or anything like that. But well, here is actually much worse. It depends on what it will be. If it's just a data harvest and it's not related to your corporate one, then kind of is okay. Otherwise, it might have a very big consequences. So once that is created, we will get those label IDs, get that email ID, and then we will store them in data store. The only reason we're storing them in data store is that if I grant consent, I have all my data stored in data store. Then the next step, if I remove that consent because I don't want that phishing email framework anymore, I don't like it anymore, and then it's not working good. In the future, there's going to be a 2.0 out, and I want to try that again, and I have already those labels created, then what we're going to do is we don't need to create those labels. We just need to reach out over the, this label is already created. These are IDs. Can we check in data store? Oh yeah, it's the same in data store. There we go. Nothing else to be done. Once that is done, we go to the email cloud functions. So the email cloud functions, as we mentioned before, there is a lot of steps that we need to dissect, send them out, and then literally do them. So it all starts when a Gmail sends a notification to the email watch pops up topic. So once that one is done, pops up executes the new email watch cloud function. Those are, bear in mind, those are all my labelings. It can be labeled as they want, to be honest, but it's just my one. So once that is done, we have the email domain, we have email links, email body, and an email outcome, right? So into the email domain is that we need to extract most likely the sender, right? Get it from the sender. What is the domain that is sending the email, and then do some couple of things over there and see if that domain comes up somewhere, or AutoML, or things that it's like phishing domain or something else over there. And once we get that thing, we need to send that the details to either the email links, where if it's one link into the email body or 10,000 links into the email body, we will need to gather them all and then one by one send them. And once that one is done, we go to the email body. This is where the text comes from, email body, right? And the email outcome. So you might think of it, but this might be an attachment, right? Well, yes, there might be an attachment, and that actually is done into the new email watch cloud function. And all depends on that we will be able to get, because the whole attachment, thing is that we just need to see what is inside. We just need to see the data and send it to AutoML and see how it is. If it's something like a code or stuff, or it's like well, if it's like a TXT or a PDF or a Word document, then we are concerned. But if it's like something like I don't know, like a batch script over there, well, we'd actually need to reject that straight away because there's a script attached to that one. And I'm sorry, but no one wants to open a script directly from an email. So first things first, like we mentioned, we have the new email watch. We got that one we started. So we get the most recent with a tag, recent message. So we get that most recent message by utilizing the utilizing the details that they were published to pops up. So Gmail API is actually will send a message to pops up, and there will be over there a tag as well. So we can get that most recent message with that tag, and we'll be able to extract details. So we extract the info from the details and we label. First things first, always label. It's actually a change over there. We get that most recent message, we label, and then we extract the info. But however, the extract info, it happens very, very fast. So we can actually get that 2 seconds done. So it depends on that labeling, that extract from the message. It all depends. We can extract the attachment, or we can actually publish that message to the email domain. So what it means, publish message to the email domain, is that we will publish that message to the email domain pops up topic, which will then invoke the email domain call function. Because if we don't have an attachment, there is nothing for us to extract. There's nothing for us to predict. If there is an attachment, we get that attachment, we download it, we send it over. We actually see the what kind of attachment it is. If it's a TXT document or a Word document or a PDF, based on that, we send it, and then we extract data, send it to the Cloud Natural, to the natural language model, and then they will be able to do that classification. So that classification will be easy, yes or no, and that's it. After that one is done, we get and we send. Next thing we do is that we do the email domain, right? So we get the domain from the sender, we predict phishing classification, right? So we send that domain, and we get 0.1, or we get 0.95, or we get 0.6. Then when we extract the URL from the text, and if there is a text, we will be send that to the email links pops up topic, sending it to the email links cloud function. Or if there is no links over there, there is just a text, we skip that one because there is nothing for us to check. Next thing we do, we go to email links if there is email links. So we extract all the URLs from that text and predict classification. So important thing to note here is that there is actually pretty much the same steps to predict one URL or to predict 10 URLs. Because all you need to do is, if there is a one URL, you send it over and you get back. So what you will do is you will get back from there and see how it is, right? If there is malicious or no, or if we think they're malicious or no. If we have 10 one, we just need to iterate one by one and send it over there, and then we will get that one. Another thing that we will utilize actually here is Google Safe Browsing. Google Safe Browsing is a public data set that is maintained and updated by Google, and it has its own public API for non-commercial use, where they have actually millions and millions of phishing URLs over there. So what is that important? Well, we know that our URL model is actually in its early stages. So what happens is that when we try to send it over and get it back, we might get a false positive. That can happen, right? We might get a false positive. But if we send it to the Google Safe Browsing, from that we will get 0 or 1. There is no in between. Either that URL is visible over there, or exists over there, or is not, or does not exist. So this is important. So we will need to retrain the model, because if I get a gmail5.com, that will be something and it's actually malicious. And I send it over to my model, and my model says I have zero point 0.2, actually the outcome that my classification prediction, zero point 0.2 is not my, but I went to Gmail, to the Google Safe Browsing API, and I get a 1, which means this exists. That after that, I will trust Gmail, Google Safe Browsing, because we are actually looking at tens of millions or something like that over there, a data set in terms of my model. So what I will do is I will send it over there, get it back, I get 1. So then my outcome from this email function will be 1, that this is a phishing. So what I'll do, doesn't matter what I do next, that's it. This email is a phishing email. That's what I think, and that's it. Like, the model will be, that will model works. And what I will do is then I will need to reuse that information in order to change this into the model. Because what I'll do is it's going to be, oh, 0.2, oh, actually, nope, you made a mistake. It's going to be, this is a phishing. So it's actually 1 because this one says this. So we can reuse that and get that classification or that URL added as a phishing in order to retrain the model. Retraining a model can be, and it is actually very, very expensive. So retraining can be done once a week or once a month or once every couple of months. It all depends on the load of emails that you receive in your mailbox. After that is done, we got the email body. Email body, quite easy. We just predict classification just because everything we extracted from before, and then we just publish that message to the email outcome. Email outcome has the email outcome pops up topic invoking the email outcome cloud function. Um, I just it just try to get that one, the labeling very fast so I can, yeah. So that has only literally only one thing over here. So we just need to get the email outcome right. So I have confidence of 0.95 here for all the steps, which is confidence is 95%. So everything that's 95% and up, and the model thinks that is that confident of like the rest of the steps and everything like that, there is a threshold that we can do just because of that. So based on that, I will be able to get. So the confidence can be up or can be down. If it's too down, if it's let's say like a 0.7, then there is a higher chance you will get higher or much more false positives. So the category that I have here is 4. So we have no attachments and no URL, which means that we have nothing there. We have attachment, no URL. We have no attachment, no URL, and we have attachment and URL. And it all depends on that, we will get the maximum value. So no attachment, no URL has a maximum value of 3, and the threshold is 1.9. That's because from the no attachment and no URL, we still send the email domain to Google Safe Browsing, and then varies between 0 and 1. So from that 3, 2 is the maximum that we can receive from our natural language model, and 1 is actually what maximum we can receive from Google Safe Browsing. That's why threshold is 1.9 with a confidence of 0.95. The whole goes the same from 5, 4, and 6. So you can see the 6 is actually threshold 3.8, just because we sent URLs and we sent the domain to Google Safe Browsing just to get that extra level of assurance. Coming back to the business process model, I hope now goes a little bit. So the first step that we have actually over here is that a new email comes in, goes to pops up, and then we invoke, right? Cloud function. The first cloud function is that the new email, right? Or the email watch, new email watch cloud function. And then based on that one, we communicate to the Gmail API, Cloud Machine Learning, and then we invoke pops up to Cloud Function, and then that's how it is. It all depends. We can invoke a different pops up, or we can just go straight away to the Cloud Function over here, invoking another pops up. So this actually, it is the steps where we have described whether or not that email has an attachment, whether or not that email has a URL. That's the only differences that we can see. There is an attachment or URL. The way how it looks, the label emails. So as you can see, pending, the yellow one, it's actually quite clear. And then over there it says, "Are you free?" So there is actually something over here with an urgency that something tries to happen to get that to me. This one is with attachment. This one is most likely not, and this is just details from the Cloud Natural Language Model uh, website on Google Cloud Platform, where you will be able to actually um, sample text that they provide from there, where you will be able actually to get sentiment over there. But that sentiment analysis over there is further where you will get, for example, Google, and will tell you this is a company. For example, it's in Mountain View, California. That's a place. California, it's a state. California is United States. All of that. So I'm quite not sure here. I can't say for 100% if the just because having the word Google, my natural language model decided it's secure. But yeah, there was nothing phishing or malicious inside that. So I would expect. The unsecured one was actually taken and a little amended from the messages dataset. So that was expected as well. The results and analysis at the end, it's that in total of around 2 months and having a test email. I forgot to mention actually at the beginning, it's a very, very important to have a test email just because you do not want to subscribe your actual email that you use to any of spam websites or anything malicious over there. So always use a test email and always open that test email in a sandbox. So what I use is I spin up actually a virtual machine on computer engine, and then I was just using an RDP to that machine and get that. So overall 300 emails. From those you can see that most of them, they had URLs but no attachments. So most of them I have received were actually they tried to get me to click something and to go somewhere, and that is actually was 70 almost 75% from all the email. And the rest, it was just, if you see the attachment URL file only 5, but attachment but no URL only 3. And that most likely came from somewhere that actually probably I was doing maybe some testing or anything like that. In more details, over here you will see that the ratio between that. So the last attachment, but no URL and URL, it actually has 100% of them being legitimate, right? So based on all of that, we get 100% over there. Based on this, we have 60 to 40 and almost 50 to 50 with no attachment and no URL. So looking at those details, that's not the greatest details. However, it actually provides a very good start in order to continue improve your phishing email framework. Yeah, and with that we conclude my presentation. I think, as Elizabeth mentioned at the beginning, if there is any questions, of course, in the chat, or if there is anyone that would like to ask something now. I tried to get a couple of details that I have been asked in the past. Think about it, what it was. Oh yeah, right. Um, if it is expensive, kinda. Yes, it is. It is maybe, but thinking about on a corporate level, not very much, but on a personal level, yes. But you probably all know there is a free credits that you can get from GCP. I think at now they are around $300 for a month, 2-3 months, something like that. I actually signed up on that, and when I signed up, it was 3 months, like a $300 United States dollars, and I did not manage to use them all. So it was around 3 months that I was doing testing and stuff, all of that, and this happened while um, I was running the training of the models. That was running the framework as well, and then I was running a VM as well that I would be able to go and open that email and see actually it in personal, so to say, how to say it. So yeah, if you have a chance, sign up over there. Those 300 will actually get you a very, very long way.
Uh, Thank you very much, Goran, for the presentation. There are a couple of questions, so let me read them for you. So first
Hmm.
of all, how did you come up with the idea to design and implement such a system?
Right. I actually came up with idea at while I was doing my master's at university. So doing my master's at university, and it was actually a lot of it was when before just before COVID started. So I was thinking about what it's going to be with my project or anything like that, and COVID started, and then we get that hike of those malicious activity. So I was thinking if just because having very or paying for any let's say like an email firewall or something like that sometimes can get a little more expensive, so called. So I was thinking how expensive will be if you would build this to a certain level that is operational, but and maintain that. So yeah, that was my initial thought about it. The actual answer to that is that it takes a little work, and it takes a little more of cautious, so to say, but overall it's not that expensive to actually run and maintain as well. Maintaining, there's not a lot to be maintaining. It just actually I think there is like a zero maintaining as well, just because everything is serverless, so nothing to be done there.
Okay, thank you. The next question is, what is the source of the data sets used for training the system? So from where you can get so many phishing email samples?
They are actually available online. So I can actually get details on that while we speak. So um, they're publicly available. So the ones that I do. So well, I think one of them, the messages was actually available on Kaggle. So and it is related. I think it's labeled like a spam messages Kaggle, I believe so. Yeah, so it's a SMS spam collection data set that you can see it over there, right? So that's the one that actually I have used. I will just pop that right fast on the chat. So that's the Kaggle one, and the URL. Um, just gonna have a look into that one and see if I'll be able to get. But they are both available online. There are actually much more as well. It's just because I have used this one because it had Kaggle, which we all know, and the other one was that it had an academic behind details. So that was the one that I have used. But I am actually checking if I'll be able to get those details. Even searching by myself, sharing from my side, to be honest, should be okay. Just because, well, it's actually gonna take out one step over there, as you will not need to clean that data.
Thank you. The next question is somewhat related to this. So, what if you would like to continuously improve the system? So, you would like to continuously train it. So, is there any way to use the incoming mails as a training source, or is it only the data presets that are available online?
Yeah. So yeah, that's, I think I've mentioned that one in a step where it is about the URL links over there. But so what you can do is actually is that you can for in my case, what I have is that this only depends on the URL, but of course it's probably going to be on the text. You would need to have something to compare that data against. So in the URL, I have sending that URL to the natural language model, and then I get details from there, and then I send that same URL to Google Safe Browsing, and then I get details from there. Then I compare those details. If natural language model says nope, Google Safe Browsing says yes, then by default we would try to trust that Google Safe Browsing, and then we will actually label that. But then what it will do is that we will store that email and say that that email is actually have it's actually a zero or a one. It depends on what we like, and that actually is actually phishing. So what we do is we will store that somewhere in some data. So once that data is done, what you will need to do is that you will get that data. So the data set you store, let's say, in a spreadsheet. There is actually a nice one API as well that I use. So Google Spreadsheet, you store the data over there, and what you do is you have the URL and you have true, which is phishing, right? And the URL over there that you have, it's already, for example, if it's already over there, you would then amend that one from if it was false to true. And then you add the new URL over there to true, something like that. So you can use this one as well. It depends. I use right now because it might be a little expensive. So what you can do is you can use that one for all URLs. So what is going to happen is that you get a new URL, you see it, that's not. Do I have it in that spreadsheet? Nope. But you would need to be very cautious here because you would need to have that let's say like a cloud function for that spreadsheet running in parallel. You don't want that one to be running or to be holding the next step for your phishing framework. So you need to be running that one in parallel, and then from there you will add it. So if the URL is there already and it's actually the same as this one, you don't do anything. If it's there but it's different, you change that one to true. If it's not there, you just add it on, and then um, after I don't know how long, then you execute your Python script, and then you actually submit that same for data set, but now with much improved data to your natural language model, and then it's going to be training. Or you can submit to a new natural language model, and then once that one is trained, you just kill the old one, and then you use the new one, which all can be automated in the steps.
Okay, thank you. The next question is that you mentioned the Gmail API,
Mhm.
and the question is, can this system be linked to any external mail servers like on-prem servers or any other mail services that are non-Gmail ones, or is it completely Gmail specific?
My framework is completely Gmail specific, just because for very for simplicity reason, I use the Gmail API for subscribing to PubSub topic.
Mhm.
So they have a new email, like a notification that they send. So that is actually on a click of a button, or like we see it over here, that is actually to just send subscribe to a topic. So that is the only reason. I would assume there would be no limitation if you would like, let's say, to, but the only thing is that on-prem needs to be able to subscribe or to send that data to GCP, or in beta to PubSub, so you can invoke that one, and then you need somehow to actually get that data to GCP. So might be much more complicated or not, but yeah, I have used Gmail API just for simplicity, mostly just because of that initial step that is very closely to PubSub.
Okay, thank you. And the last question is that is there any way to expand such a system to use a shared backend that gets trained by multiple sources to increase efficiency? For example, to connect multiple companies and aggregate the input for training the data and increase the efficiency.
It can, but um, the way it's designed right now, the way it's implemented, it cannot. Just because we talk about me getting that via API, and actually I used a plain text from that email and compare it into the, let's say, like a natural language model. So that is actually something that it's like by default forbidden. So the way it's designed right now cannot be used with a shared company, but I would think maybe it can be used something in the future where we'll be able to somehow get that data, but also we'll need to get some kind of consent or something like that. but in the way that the end user to be able to send that and then aggregate in the backend or something like that. But the way it is, it cannot, sadly.
Okay, thank you. So that's all regarding the questions. There are no more questions. If anyone else has any questions, you can put it in the chat. If there are no more questions, then I will thank you for the presentation and I will hand over to Elizabeth again for closing the event.
Thanks very
Thank you,
much.
Zygmunt. And also thank you, Goran. This was quite enlightening, hopefully not just for me, but for all of you as well. And I would also like to thank Zygmunt for his tremendous help in organizing and facilitating this whole event. Really, we couldn't have done it without you, so thank you. If something is not so clear or you missed something, be sure to check out our YouTube channel because we will upload the recording of this meetup. And you can drop your comments there as well, and maybe we can answer them. And if you are interested in further GCP related events, meetups, be sure to check out our community, GDG Cloud Budapest, so that you can be among the first to know about our upcoming events. I would like to thank you all again, especially Goran Minov, and Zygmunt, and for your help and all the work you put in this, and for all our attendees. And I hope that we can see you again at our next event.
Thanks
Thank
very
you.
much. Yeah, it was a
Goodbye.
pleasure being here. Bye.
Thank you.